So what we found is that when we dropped a t-shirt over time, the t-shirt, what did it do when we looked at the data? It sped up, so that meant that it would fall at a faster rate. About how long did it take before it hit the ground usually? Yeah, it wasn't even a second, right? Wasn't even quite a second. So what it did is it would fall slow and then speed up and then speed up, and as it sped up and sped up and sped up, it went faster and faster. So it did it in a fraction of a second. It didn't even last a whole second. But that's what the graphs kind of look like. Now we measured it backwards, so it went up. But that's what it would look like if we made the ground equal 0, right? And we made the height of our motion sensor at 1 meter per, or 1 meter. So our graphs looked a little bit different because of the way we orientated our lab. But just think about that. As I had a t-shirt, all right, this is our t-shirt, and I drop it. The velocity here, the initial velocity is 0, as is our initial position. Well, actually our initial position is 1 meter. Well, as it goes a little bit further down, the velocity increases. And so because the velocity increases, over time, the distance that it travels increases as well. And just before it hits the ground, the velocity is going to be at its highest point, right? It's going to really be increasing. So then our displacement is going to really increase as well. And so what that means is as it speeds up, as it gets closer to the ground, the distance or the time in which it takes to hit the ground is faster and faster. So now the velocity over time our initial velocity is 0 over time, and I'm going to expand this out and draw a little bit more out of scale. But our velocity was going in which direction? Up or down? Down. So what was my velocity? I put the arrows as pointing up, meaning they increased in value. What I really should have done was what? Drawn my arrows going down. So it became more and more negative. The velocity increased over time. And what we would have found is that the velocity would have increased at a constant rate. Does anybody want to take a guess as to what that constant rate was? 9.8 meters per second squared. So the slope of this graph right here is a negative 9.8 meters per second squared, which we know is what? Well, yeah, you're close, you're half right. Acceleration due to gravity, right? We got to be careful that when we say it, we got to say it that way, right? Acceleration due to gravity, which always happens in free fall. So an object in free fall, what is the acceleration on it? Always 9.8. Why did I write a negative 9.8? Because it's going down. Now, when you take a higher level physics class, well, actually, we'll do some stuff later on. We can choose what's going to be positive and negative. But most of the time when we're doing free fall, going up is positive and coming down is negative, right? So that's pretty much it. That's it. That's all we had to do for problem number 61. Does anybody have any questions on that? Huh?